Good morning, my dear children. I welcome you for the second session of chapter number 6. We are doing chapter number 6, heat and energy. Yes, and from here we have completed Unit A in our last class. In Unit A, we learned about heat and temperature. If you all remember, we have learned about these two topics. Along with these two topics that we have discussed in the last class, we have learned about anomalous expansion as well, isn't it? Right, so we have learned about anomalous expansion of water, isn't it? That is, water starts to expand, okay, on cooling. You all know that whenever something is heated, it expands, and when something is cool, it contracts, isn't it? But water is such substance which on cooling it starts to expand. When you cool water from 4 degrees Celsius to 0 degrees Celsius, it starts to expand. So this expansion is called anomalous expansion. This is the thing we have learned in our previous class, isn't it? So today we are going to begin the second unit, that is unit B. Okay, unit B. So unit B, it says energy flow and its importance. So this is what we have in unit B. Here we'll be learning about energy flow. Okay, and how is this energy flow important for living beings? All right. So first of all, let us understand about our ecosystem. Now, what is ecosystem? You must understand this. Now, ecosystem means it's a place, it's a unit, okay, where living and non-living things coexist. They exist together and they survive. Okay, so what is ecosystem? It is a unit which composed of living things, okay, living things, okay, and non-living things. Okay, so living things, what do we call to living things? So living things are called as biotic. What do we call to living things? Biotic. All right, and to non-living things we call them as abiotic. Okay, abiotic. So what are biotic? Biotic means living things. Okay, like the one which produces food, the one which eats food. Okay, understand? So basically they are producers, consumers, and decomposers. And abiotic components are what? Light, heat, rain, humidity, inorganic, organic substances means those substances which are not livings. Understand? So a unit composed of biotic and abiotic components is called ecosystem. So this would be the definition or the meaning, okay, of ecosystem. So you can underline this. Okay, now the existence of living beings such as plants and animals depend on the flow of energy in them. So the existence, how is a living being able to survive or sustain? Okay, it depends on, okay, the flow of energy, the flow of energy in them. So energy is needed for all the biotic activities. The most significant source of energy for all ecosystem is the sun. So that is why we call sun as the ultimate source of energy. We regard sun as the ultimate source of energy because whatever the energy, whatever may be the forms of energy that we get in earth, okay, they are actually coming from the sun. So that's why we consider sun to be as the ultimate source of energy. Now the energy received on the earth from the sun is utilized in different ways. So you know that when it's a very sunny day, the sky is clear, what happens in that day? Okay, what happens? The energy the earth gets is coming from the sun. So this energy that we get from the sun is utilized in different ways, isn't it? Yes. So nearly 56 to 60%, okay, part of the incident energy is absorbed by the atmosphere. So you must see or realize that the energy that is coming from the sun, out of 100%, 56 to 60% of this energy is absorbed by the atmosphere. So atmosphere absorbs this amount of energy. So what is the remaining one? The remaining is your 40%, approximately 40%. Now out of this 40% also, nearly 10% is utilized in heating the water and land, and only 8% falls on the plants. So see, you can imagine that out of 100% of the energy that is coming from the sun to the earth, 56 to 60% is absorbed by the atmosphere. Okay, whereas out of that 10%, the remaining 10% is utilized in heating the water and the land. Okay, and only 8%, see, only 8% is reaching the plant. Why we are considering plant here? Because you know that plant is the a biotic component which is responsible for the production, the food that we get. Okay, all you must understand that all living things like animals, okay, especially animals, they survive because of the food produced by the plants. Okay, so plants absorb most of the energy, okay, falling on them. Out of the absorbed energy, plants use only 0.2% energy in the photosynthesis for producing their food. So they are called producers. Now who are called producer? Plants. Okay, you must realize here that plants are the producers, because plants prepare their own food by the process of photosynthesis. And for the process of photosynthesis, what do we need? Sunlight. And sunlight ko pani out of 100%, only 8% reaches or falls on the plant. Alright, is that understood? Now let's see the food chain. Now in ecosystem, photosynthetic plant and bacteria acts as producers. So not only plants, but there are bacterias. Okay, these bacteria contain chlorophyll in them. So those bacteria or those organisms which have chlorophyll in them, the green pigment, they can produce their own food. So that's why they are called as producers. The food synthesized by producer is utilized by primary consumers such as krill. So if you see the figure, in this figure you will see here we have the, okay, you can follow your book. On the book you will see that here is the krill. Okay, the primary consumers are eaten by secondary consumers such as small fish. So here we have the small fish. You please follow your book. Okay, on your book you'll see this figure. Okay, and in turn they are consumed by tertiary consumers such as large fish. So here you have a tertiary consumer, which is a large fish. The tertiary consumers may be eaten by the man here. Okay, the man may be the last consumer in this chain. Okay, in this chain of energy transfer when he eats the fish. This simple food chain is shown in figure number 6.6. So this is how the energy flows from one organism to another. That is from primary, okay, first it goes to primary, then to secondary, then tertiary, then it comes to the man. So you see that the plant is the main source of what? Energy in this food chain. See, plants are preparing their food by the process of photosynthesis. And how the plant prepare their food? They prepare their food from the energy that they get from the sun. Understand? So indirectly, the living things are depending on sun, because if there is no sun, there is no light, plants will not be able to produce the food. And if plants do not produce food, okay, the food chain will break, and hence the entire ecosystem will get disturbed. Okay, so now let's see how the energy flows. Now figure number 6.7, okay, shows the energy flow in the ecosystem. So if you see figure number 6.7, you have this thing in your book, but here I have taken them in part by part because I cannot fit the entire page in my screen here. So if you see, okay, on the book figure number 6.7, you will see that at the bottom you have the sun. This sun is the main or the ultimate source of energy, and it supplies energy to the producers. And what are the producers? Plants, if you see here. Okay, now let's go back here. The producers, that is photosynthetic plants, synthesize organic substances by the process of photosynthesis. That is, they bind the simple compounds with the help of solar energy in the complex organic substance. This complex organic substance, in simple language, we can call them as food. Okay, food. The chemical energy so stored in plant is called the gross primary production. So you can underline here. The producers themselves first use the synthesized organic substance in the process of respiration, in which some energy is used in oxidation of organic substance. Is that okay? So you can find every sentence that I'm showing you here on your book. Okay, so here you see that plants is producing the energy, but a small portion of that energy is taken up by the plants. Okay, so the chemical energy in form of food so produced by the plant is called the gross primary production. All right, now the rest of the energy called the net primary production is stored for the growth and development and important metabolic processes. So in figure number 6.7, the gross primary production by the producer is 20,810. So in this figure you will see here 20,810 calories is the energy, that is the total energy is stored in form of chemicals, that is in form of food in the plant. Okay, clear? And out of this 20,810 calories of energy, calorie is the commonly used unit of energy, heat energy. Okay, out of this 11,977 energy stored in the respiration, that is it is used up by the plants itself. So here this 11,977 calories of heat is used up by the plant itself. So out of 20,810, this is the energy that is consumed by the plant itself, and the remaining energy that is this one is called as the net primary production, that is 8,833 calories of energy is the primary production, net primary production. Okay, so this is your net primary production. Now if you see the next paragraph on your book, you will find this: the next primary consumer, that is herbivorous. Herbivorous means those plant animals which depend on plants, means plant eating animals, they eat only the plants, obtain their food from the producers, so they obtain only a small part of energy from the producers, and the rest is wasted in decay of the producers. Okay, so a small part of the energy obtained by the primary consumer is utilized in respiration. So primary consumers also, here you have primary consumer here, they are herbivorous, plant eating animals. Okay, they also, what they do, they eat only a portion, okay, whereas the rest is wasted in the decay of what? Producers. Are you getting my point? Because you see like when you feed grass to the cattle, they will not eat entire part of the plant, isn't it? They eat only the leaves, right? And the remaining stem and branches are left over. So they also contain, or they also have some energy stored in them. So those energies wasted in the decay. Okay, kuera jaन्छ त्यो पार्टहरु, isn't it? Yes. Okay, and the small part of the energy is what? Used by the primary consumers in the process of what? Respiration. Okay, now in respiration, through which they perform metabolic processes of their body, and the remaining part is stored in them as food. So again in figure number 6.7, the primary consumer obtain only 3,368 energy. So here you see 3,368 energy is only received by the primary consumers, and out of this also what happens, 5,646 is wasted in their decay. So here this is the decay of this primary producers. यो चाहिँ के भयो, हाँगा बिगा ब्रान्चेस, ओके, स्टेम्स जुन चाहिँ चाहिँ एनिमल्सले खाँदैन त्यसमा भएको एनर्जी चाहिँ यहाँ वेस्ट भयो, के भएर कुहिएर गयो त्यो, isn't it? So only 3,368 calorie is used. And त्यसमा पनि what happens, the producers use 1,890 calories of energy is used of in respiration. So यहाँ 1,890 is used up in respiration, and only the remaining portion, that is 1,478 calories of heat energy is stored in the primary consumer as food. Are you getting my point? So afterwards, a small part of the energy stored as food in the primary consumer is obtained by, now let's see in the next page, okay, by the secondary consumer, that is carnivorous. They again make use of the plant part of the energy in respiration, and rest is stored in them as food. So in figure number 6.7, the secondary consumers obtained only 383 calorie energy from the primary consumers, and the rest of the energy, that is 1095 calories, wasted in their decay. So the secondary consumer utilizes 316 calories of energy in respiration, and the rest of the energy, that is 67 calories, is stored in them as food. So let's go back again to the figure here. So from here you see that 1095 calories of heat, energy, is wasted again in form of what? The parts like bones, some of the parts. When carnivorous animals are eating these herbivorous animals, they do not eat the entire body of the animal. They leave many parts uneaten, so they get decay and the energy is lost here. Only 383 calories reaches the secondary consumer, that is the carnivorous animals, the animals which eat other animals. Okay, and out of this 383, 316 is used up by these secondary animals in respiration, and only 67 calories of energy is stored in them as food. Out of the 67, again 46 calories is wasted in decay, okay, and only 21 calories is received by the tertiary animals. Okay, tertiary consumers again waste up use 15 calories of energy for respiration, and 6 calorie reaches up to the end of this food chain. All right, so here by repeating the sequence, the tertiary consumers, that is carnivorous, obtain energy as food from the secondary consumers and utilize a small part of it in respiration, and the remaining energy is wasted in their decay and decomposition. So in figure number 6.7, the tertiary consumer obtain only 21 calories of energy from the secondary consumer, and the rest of the energy, that is 46 calories, wasted in their decay. So out of 21 calories obtained by the tertiary consumer, 15 calories of energy is used in respiration, and 6 calorie energy is wasted in their decay. So the energy flow in this ecosystem is thus linear, means it flows only in one direction. So the flow of energy in a chain, in a food chain, okay, is linear. Linear means in one direction. Unidirection means the energy cannot reach back to the sun. You see that sun is the ultimate source of energy. Energy is received from the sun, isn't it? Yes, and it goes till here, till the death. But you see that energy is flowing from sun towards here, but it is not going back to the sun. Okay, so it moves in a fixed direction. At the end, the energy reaches to the degraded, that is unuseful state. So it does not return to the sun to make the process cyclic. So the flow of energy in the ecosystem is not cyclic. It's not cyclic. It is one direction. It is unidirection. Okay, so the energy flow in the ecosystem can also be understood in the form of a food chain, as shown in figure number 6.8. So you can see this figure on your book as well. So here you see that energy is first received from the sun in the form of solar energy. Plants, they absorb this energy, okay, and by the process of photosynthesis they produce food. That's why they are called as producer. Understand? Yes. So heat of evaporation, conduction and convection takes place here. So some part of energy is wasted here. Now some part of is used by the plants for respiration, okay, and the net gross production, that is 20,810, what happens, 11,977 calories is used up by the plants for respiration. So the net production is 8,833. So you can imagine this was the energy that is received by the plant, okay, but now out of this much is used up by the plants for respiration. So this is now reaching to the primary consumer. Understand? Yes. Out of this also, this one is lost due to the death and decay of the plants. So this 3,368 energy is received by the primary consumers. Out of this, 1,890 is used up by the primary consumers for respiration. Understand? Yes. And there are some laws because of the excretion, isn't it? You all go to the washroom in the morning. Yes. So there also there is a part of loss of energy when you are going for excretion. So plants also excrete, and the net production that is stored in them in the form of food is 1478 calories. Okay, when it is consumed by secondary carnivorous animals, or you can say secondary consumers, only this part of the energy is reached, because this part of the energy is lost in the decay of the uneaten parts of the primary consumers. Okay, out of 383, 316 calories is used up by the secondary consumers for respiration. Understand? And 67 reaches to the tertiary consumers. Out of 67, again, because of the death and decay of some of its parts, 46 calories is wasted there. Okay, understand? And 67, but only 21 reaches to the tertiary consumers, and out of 21 also, so what happens, 15 calorie is used up by the tertiary consumers for respiration, and the remaining 6 is stored in them until they die. So here you see that the energy is coming from the sun, and it is ending up here after the death of the tertiary consumers. So here you see that it is a unidirection. It is a single direction, or you can say it is a energy flow, or the flow of energy is a linear. It flows in a linear direction. It does not go back to the sun and completes the cyclic process. So it's not a cyclic process. Is that okay? All right. So now let's go to the next page. You can turn your page in your book. Okay. The next page, you see the application of thermodynamics. Okay. Application of laws. Okay, laws of thermodynamics in energy flow. Now, first of all, let us understand what is thermodynamics. What is thermodynamics? Now, see, to make you all understand in a simple language, we have learned about heat. Yes, we have learned about temperature, and we have learned about energy, and we have learned about work also, isn't it? Yes. So the study of these things together, or you can say the study which shows the relation of this heat, okay, the relation of heat, temperature, energy and work among themselves, okay, is called thermodynamics. So thermodynamics is actually the study of relations of heat, temperature, energy and work. Okay, so you can apply these laws of this thermodynamics when you are learning about the flow of energy, or you can simply say energy flow. So the flow of energy is the process of entrance of or transformation and diffusion in ecosystem is governed by the laws of dynamics. So here you see that in the ecosystem, as the energy enters, as the energy, okay, enters in the ecosystem, okay, from the sun, okay, what happens, you see some of the energy, some portion of the energy is transferred from producer to the primary consumer. From the primary consumer it goes to the from the primary consumer it goes to the secondary consumer. From the secondary consumer it goes to the tertiary consumer. So there is a transformation of energy from one consumer to the another consumer, and some of the energy is also lost in the what process of transformation, isn't it? So to understand this concept, you can apply the laws of dynamics, thermodynamics, okay, and there are two laws of thermodynamics. How many? Two laws of thermodynamics. Okay, so according to the first law of thermodynamics, energy can be transferred from one form to the other form, but it can neither be created nor destroyed. So you can underline this and put a star mark here. The first law, okay, you can rub this from here. The first law of thermodynamics, what does it say? It says that energy can be transferred from one form to another, okay, one form to another, like the energy from the solar sun in the form of solar energy, okay, it is stored up by the producers in the form of chemical energy. So here you see that solar energy is now converted into chemical energy. So you can transform the energy from one form to another, okay. from chemical to electrical, from electrical to sound energy. You can transfer the form of energy from one form to another. But very important is that you can neither create it, you cannot create energy, nor you can destroy energy. It's not possible for us to create energy as well as to destroy energy, but you can obviously convert energy from one form to another. For example, when you are burning coal, coal has chemical energy stored in them. So when coal burns, it gives you heat energy. So chemical energy is converted into heat energy here. So you are transforming one form of energy into another, but you cannot create energy by yourself. It's not possible. Are you getting my point? So when certain amount of one form of energy is destroyed, then the same amount of another form of energy is created, as shown in figure number 6.7. So this is our first law. Now the second law. Okay, you can underline the second law also. According to the second law, from here you can underline the second law of thermodynamics, which says that when energy is put into work, a part of it is always converted into unuseful, very important thing to remember here, unuseful form as heat, mainly due to friction and radiation. So this is what is said by the second law. Okay, so second law of thermodynamics says that energy is always converted into some part of energy. Okay, some part of energy is always converted into unuseful part, and this part is usually in the form of heat. Why? Because of the friction, okay, and radiation. So this unuseful part of the energy actually degrades the flow of energy. So in all such cases, the total sum of the useful and unuseful energy remains constant. So in figure number 6.7, the energy used in respiration and in decay or death appears as unuseful heat energy, because this energy does not reach to the consumer to the next stage. So the energy which does not reach to the consumer in the next stage can also be called as the unuseful energy. Okay, so just like a machine, in ecosystem also the energy transfer is not 100%. So another important thing to remember, in ecosystem also, in ecosystem you can write, in ecosystem the energy transfer is not 100%. A portion of the transferred energy always goes to the unuseful form in accordance with the second law of thermodynamics. So this is what our second law of thermodynamics says. Second law says that some part of the energy is always converted into such form which cannot be used, and that form is called unuseful part. Okay, so let me recall again. First law says that you can transform energy from one form to another, but you cannot create or destroy energy. Energy in a system remains constant. You cannot create, you cannot destroy, but you can transform from one form to another. This is what our first law of thermodynamics says. And what does our second law says? Second law says that there is always what? Loss of energy during the transfer of energy from one form to another. This form or this energy which cannot be used is called unuseful, okay, form of energy. Is that understood? So I hope you have understood the chapter now. Yes, so we saw today, let me again recall, we saw the flow of energy in the ecosystem. We understood the concept of ecosystem. Then we saw the food chain. Then we also learned about the flow of energy, how the energy, or what is the amount of energy that is produced by the producer, that is plants. Then we saw the flow of this energy from from producers to the primary consumers, then from primary consumers to the secondary consumers, and from secondary consumers to tertiary consumers. And at the end we saw, or we understood the concept of this energy flow by the application of the law of thermodynamics. Okay, so how many laws of thermodynamics are there? There are 2 laws of thermodynamics. All right, so I hope you have understood. If you have any confused, if anywhere you find there is a little bit confusion, you can always ask me. All right, so I hope you have understood. So that's all for today. Thank you.